Do you want me to get rid of that one in the
You said the negative
Asian
was
Yeah,
Chinese
thing? The Chinese box?
The
yes,
biohazard
the
box.
biohazard
You know I
box.
do that on
Yeah,
purpose.
okay.
You said the negative was streptococcus.
It's right there. I put them down there for you all. You see them? Analysis?
Yes. Okay, got you.
Okay. So now, the next plate is called the phenol ethyl agar plate. It's also known as the phenol ethanol agar plate, or we just refer to it as PEA. This plate has alcohol in it, and so you can see that can you see the little brackets, and then you have ETOH in it? Mm-hmm. That means the concentration of ethanol. Okay. That's what that means. So this has got ethanol in it. So in order for you to be useful to you, it has to be fresh. Okay. You cannot use a 2-week-old plate. They don't work. But what happens is because the alcohol is in here, it's going to inhibit the growth of gram-negs, but allow gram-positive organisms to grow. Okay? So what you're going to do today is you're going to follow what's on here. Everybody's going to do this. You'll divide the plate into 3. On one side, you will inoculate, what is it, Andres?
So everyone gets their own plate?
No, this is per cohort.
Okay.
E. coli, Staph aureus, and Strep pyogenes, right? E. coli will grow, but it'll be real slow. It doesn't like it. But remember, this only inhibits. It doesn't kill. It only inhibits. Okay? So, once the alcohol has been volatilized out of the plate, E. coli goes aggressive. It starts to grow again.
So you're going to take alcohol out of the plate?
It'll go out just because it normally goes out.
Okay.
Yeah, because it's just...
Alcohol is volatile. It doesn't ever stay anywhere it goes.
Like your
That's
body?
why if you put alcohol on your skin to clean the dirt off, it dries really quickly.
Then
Okay?
you have to...
Or when you do the hand sanitizer and then it
Dries
dries.
quick. Okay.
So when you're incubating these and everything, like how like the alcohol remains in it? Like, do we take
For
the pictures
about
fast?
a week.
Oh, for
Okay.
real?
Oh, okay.
And then after that it comes out. But it's coming out.
So we'll still have
A little,
the ability
it'll
to...
be there, but next week it'll be gone.
Okay, so like
So
maybe
when
a
we
little...
come back on Tuesday, you'll see that E. coli will probably have start growing, but it won't be like
Crazy.
It won't be crazy.
Okay.
So when is this plate important to use?
For gram positives?
To isolate gram positives from an unknown when you have an aggressive gram negative. And 5 of you, for your unknown, Emily, will get an aggressive gram neg. And it'll drive you crazy until you figure out how to isolate it, and then it'll be fine. Okay? So today you're just going to inoculate, yay? Next plate is blood agar. Do you see how this plate is actually, it's beautiful. This is a Myra special. Myra and Bailey are 2 of the few individuals that know how to pour a blood plate besides me.
Really?
Right. This is gorgeous.
It is pretty.
Because usually when they do it, it turns brown on them and becomes chocolate agar because they put it too hot. They put the blood in there when the media was too hot, it burned it, right? Or they contaminate it with Proteus and Proteus grows like crazy. This is perfect. This is just gorgeous. These
It is a good red color.
These
Yeah.
plates,
It's like
Like, that's like a
Manila.
these
lipstick
plates
colors
cost
them.
about $8 a piece.
Damn.
So we make our own because, we're Riverside.
So you guys remember use 1, not 2.
So what will happen is you're going to do a cohort thing today, but during the unknown, you'll notice that I'm going to take all the blood plates and hide them because
Why?
people go crazy on them.
Oh, okay.
And they start to waste them for no reason. And so if you want to use a selective or differential plate, you have to come to me and you have to ask for it and you have to justify why you want to use it. I won't give it to you just because. Are you with me? That's part of the process. Part of the process of learning is having a plan.
So because they're expensive, they're might.
But mostly
not need
because I don't want you to just waste them.
So
Yeah,
if
we
you
might
steal
not
them
need it
right
too
now,
much,
what
though.
will
You
happen
won't.
to it?
A lot of people won't.
Save this for later.
Because what this does is this is an enriched plate,
Okay.
but it's a differential plate too. And we're much more interested in the differential capabilities of this plate. It will differentiate the types of toxins that are produced by the microorganisms. So if the organism produces what we call an alpha toxin, it has a name, we just call it alpha toxin, then what they do is they partially break down the red blood cells, and there's a green zone that appears around the colony. It's right over there. Okay? We call that alpha hemolysis. So you can see it's right there. It's got that little kind of religious fishy thing. You see it? And that's an alpha. That's a sign for alpha hemolysis. Partial breakdown, green zone around the colony.
Okay.
The organisms that produce a beta toxin will completely destroy the red blood cells, and they'll clear the red blood cells. They'll digest them completely. And so there'll be a clearing around the colony. That's called beta hemolysis, complete breakdown. And the last one is what we call gamma hemolysis. But gamma hemolysis is just kind of a funky way that we say there's no real toxin being produced. Because
What was that word?
gamma hemolysis.
Okay.
So it has it looks like a really weird little R. You see it down there?
Oh yeah,
Yeah.
like an upside down fish.
Okay, good. But so that just means that the organism didn't produce any toxins and therefore didn't break down the blood, and so the blood remains red. Therefore, you have a red zone around the colony. Okay? So you all are going to take 4 different organisms. You're going to draw one line on this, right? Except for Kai. Kai, will you take this plate? And will you do a 4-quadrant streak with Streptococcus pyogenes on there?
Yep.
So that we can see the hemolysis of that organism, because that's one of the strongest organisms that produces.
So the plate will be like clear whenever we see it.
So we won't get to see the pretty red anymore after it's done.
It'll be some red, but most of it'll be clear.
Yeah, I think he's, yeah.
So everybody else in that cohort just needs to follow the regular. Kai's going to do an extra thing for the class. Okay?
Thank you, Kai.
All right. Now, my favorite plate of them all is mannitol salt plate, just because it's very powerful. Mannitol salt plate has mannitol as a substrate, and we're looking to see whether or not an organism can ferment mannitol or not. It also has 7.5% sodium chloride in it. So this is a hypertonic environment, and only halophiles will grow on it. So if the organism grows on this plate, by definition, it's a halophile. It is a Micrococcus or it is a Staphylococcus, because you can see the big old word that Spencer has written down at the bottom, halophilic, right? Good. So in here is mannitol, that's a substrate, 7.5% sodium chloride, and then it's got the pH indicator phenol red. You all are going to divide up into 4 plates. You're going to put one organism in each of those areas. But the organisms that will grow on this plate but not ferment, you'll have kind of a little bit more fuchsia color around. So that is going to be an organism that is a halophile. It's either going to be Micrococcus or Staphylococcus, but not Staph aureus. Staph aureus will grow in here, but it'll ferment mannitol. Therefore, the area around the colony will turn yellow. Okay, yellow. Okay? If it doesn't grow on this plate, then what?
It's negative.
It's gram-positive.
It's a gram-positive what?
Or staph.
Anything else that's not a staph or a micrococcus.
Mm-hmm.
Because the gram-negs won't grow, and the gram-positive cocci that are catalase negative won't grow, except for one. Okay? So, Andres, will you do a 4-quadrant streak on that with Staph aureus so that we can see it in all its glory? Good?
Yes.
All right, the last thing is Andres was telling me earlier that he read this thing. Yeah?
Sorry, with this plate, so we'll do it like.
Four divided into 4s.
Okay.
And in each area
Is
put a
it
different
street plate
organism.
method or how?
No.
Okay.
Oh, I'm sorry. I thought there was 5 of them. That's my bad.
So no street plate method.
Mm-mm. Okay, so now, this particular test here is called the Staffy-Tech. And the Staffy-Tech is a beautifully selective, beautifully identification test for Staph aureus only. So only Staph aureus will be positive. And what happens is in this particular tube, the reagent, which we have very little of, has the antibody that's bound to blue latex particles. Okay? So now let's do a little skit. So Annabelle and Fatima and Emily come up here, and I want y'all to be like this. Just do this. come here. I want y'all to be the staphylococcus, okay? So now I need somebody who's blue. Nobody's got a blue color.
You.
How many only guys are blue? Okay, that doesn't make sense. Okay, fine. Well, so Amber, come here. Amber's gonna be stand over here. Amber's gonna be the latex part.
You want me to move?
Yeah, just sit right there. I'm gonna be the
Give
antibody.
me, Andres, give me the plate. I'll put it over.
So I'm gonna come over and if you hold your arms out like this, I'm gonna bind you all up. Like it's not gonna be weird or anything. You're not gonna make me sick, are you? Okay, good. So I'm the antibody, right? This is the way I look. Amber, put your hands on my shoulder.
Yay!
Okay, good. So now I'm the antibody, and Amber is attached to me, but she's latex, yes? So I'm only attracted to Staphylococcus, and there they are. So I'm coming over. Amber, follow me.
I don't know.
Don't break apart.
Okay.
Just
Okay,
don't piggyback.
So, go like this. I'm going to come over, and I am going to find.
Wait, what are these
I'm
three
going to
again?
bind up all of these cells all together. Yeah. So I got them all captured. I'm the antibody, and I got them all captured. But Amber is the plastic. She's the latex. And the more and more of the latex that shows up, the more and more we see particles. Okay.
The more and more what?
We see particles.
Particles.
Okay. So now you'll notice that this plate has got two little areas. One of them I've labeled Staph aureus, the other one I didn't label. So what I'm going to do is I'm going to put a drop. Somebody wants to film?
Oh.
Do you want me to video?
Yeah, because you did it good last time.